A very good morning. Myself, Dr. S.M. Mishra. Today, we will be going to discuss about the nanomaterials. First, we'll try to understand what are the basic concept, what are the basic subtopics which are included in this nanomaterials. Here, we'll be going to see the basics of nanochemistry. It includes definition of nano, then the carbon is new form of a carbons, that is the carbon nanotube to the graphene, one dimensional, two dimensional and three dimensional nanostructured material, and their different properties like mechanical, physical, chemical and the different optical properties, right? Also we'll be going to see the different applications of nanomaterials, like the applications of nanomaterials in molecular electronics, nanoelectronics, then nanotechnology for the waste reduction and the improved energy efficiency, then the carbon nanotube for energy storage and the hydrogen storage in a carbon nanotubes, then nanotechnology which is based on a water treatment strategy. First, we'll try to understand what is meant by the nano. So, nano, it is a Greek word which means dwarf. So, dwarf means a very small object or a material, and basically the material having dimension between 1 nanometer to 100 nanometer, means 10 raised to the power of minus 9 to 10 raised to the power of minus 7 meters. So here basically the definition we can talk about regarding nanomaterials. So these are the materials which have at least one of their dimensions in the nanometric range, that is 1 nanometer to the 100 nanometer. So for example, here the in day-to-day life we come across the different examples like human hair. It is about 10 to 50 nanometer in a diameter. Then red blood cells which are 2 to 5 nanometer. Then a DNA molecule is about 2 nanometer in a diameter. Then the carbon-carbon bond, it is about 0.12 to 0.15 nanometer in a length. Then we can say that if we stack the 5 atoms of a silicon, it would accommodate the size of 1 nanometer thickness. Moving towards another different example, say for example if we talk about the ant which is of 5 nanometer in its length, then the fly ash 10 to 20 micrometer, right? Then red blood cells 2 to 5 micrometer. So in day-to-day life we come across the different molecules which are already exist in our surrounding, in our nature, right, which are in a nanometer range. Then we'll try to understand why nanomaterials, why they are so special, right? Because say for example if we take a coin of a gold, then we know it is shiny soft yellow metal and which is having a melting point 1064 degrees centigrade, right? And it is also an excellent electrical conductor. If we break the coin into two pieces, then the half of a gram piece is also yellow, right? Has the same texture and same color, and it is also a good conductor of electricity. Like this, if we go towards the nanometer range, if we cut down the gold pieces into such a powdered form in a nanometer range, that is up to 10 raised to the power of minus 9 meter, means 1 billionth of a meter, then all the properties of the bulk gold material changes, right? Means the whatever the property which has earlier, when we are talking about a 1 gram gold, that is the bulk material, and if we talk about the nano material, all the properties would be going to changes drastically. See here, the basic property, like say for example color. Earlier, when we were talking about the 1 gram of the gold, the color of the gold was yellow, right? But when we talk about the nanometer range gold particles, then it was no more yellow in color, but it appears to be ruby red to the bluish in solution, right? This we can observe in the next picture, that when we are talking about the 80 nanometer gold particle, it seems to be the here pink color, and when we are talking about the 20 gold particle of fine size, that is the 20 nanometer, then the color again changes to the here ruby red color. So as we are moving from the bulk particle to the nanometer range, the properties of the nanomaterial changes drastically. Here in day-to-day life, we again come across the different examples. Say for example, if we talk about the copper. Copper is opaque in a bulk state, and when we move towards the nanometer range, when we reduce its size to the nano size, then it is transparent. Then aluminium become combustible in nanometer range. Then silicon becomes a conductor. Gold, which is inert in a bulk state, it becomes active catalyst in the nano world. In day-to-day life, when we come across the different research paper, we came to know that in different research paper, they are using the gold nanoparticle, silver nanoparticle as a excellent catalyst. Here, gold nanoparticle or any nanoparticle, why they are so useful, why they are having the more importance than the bulk particle, bulk material. Here, these are basically because of the certain property, like because of we are getting the high surface area, then their rapid diffusion, then easy dispensability, and the high reactivity. So because of these four important property, these nanomaterials are very important, and they are having a wide range of applications. This nanomaterial we can observe with the help of a scanning electron microscope, transmission electron microscope, and this object, at least we know that it must have at least one dimension, either height or a length or a depth, that measures must be in a nanometer range, that is from 1 to 100 nanometers. So here again we have some examples. We know that 1 inch it is equal to 24.5 million nanometers. A sheet of a paper, if we observe, it is about 1 lakh nanometer thick. A human hair, it measures roughly 50,000 to 10,000 nanometer. Human fingernail, it grows 1 nanometer per day. So, what is mean by the nanoscience? So, it is basically the study of nanomaterials. So, study of nanomaterial by manipulation of the structure and the component of a system at the nanometer scale, that is in between 1 to 100 nanometer. So, what is mean by the nanoscience? So, the study of manipulation of structure and component of a system at a nanometer scale, which ranges between 1 to 100 nanometer, and because of which here these nanoparticles, these are having the novel, significantly improved physical, chemical, and the biological property. So, this is basically the nanoscience. Here, it is basically the study of properties of a material at a nano scale. So, what is mean by the nanotechnology then? So, with the help of this property, we can use it, we can apply it into the different manufacturing processes for the preparation of different object on the basis of their important property, that is the optical, chemical, mechanical and different property, because of which we can use it for the manufacturing of this material. So that is nothing but the nanotechnology. It is basically the application of their property for manufacturing. So classification of nanomaterials. Nanomaterials can be classified on the basis of dimensionality, morphology, composition, uniformity and the agglomeration. How they'll be going to agglomerate. Out of which we'll be going to see the classification of nanomaterials on the basis of dimensionality. So the nanomaterial can be classified as 0 dimensional, 1 dimensional, 2 dimensional and the 3 dimensional. See, these are the certain examples of different classes of this nanomaterial. Say for example, 0 dimension, it is a solid nanoparticle. We can say these are exist in a form of a cluster. Then 1 dimensional nanowires, nanorods, 2 dimensional film or a coating. Then 3 dimensional means the pillars or the nanotubes. So here 0 dimensional means what? See, 0 dimensional means here we know that particles, these are having the 3 dimensions, that is the x, y and z. So in this all the dimensions, all the x, y and z dimensions are reduced to the nanometer range. They all will be below the dimension of this particle will be less than 100 nanometer. So here the movement of electron is restricted in all the direction. Say for example quantum dots. Then here this nanoparticles, they are having a shape just as a like spherical, cubical, polygonal with the size range of 1 to 50 nanometer. The very well known example is a fullerene, that is it is also called as a buckyball or carbon 60, which is consisting of the pentagons and the hexagons. One dimensional nanoparticles means here in this case the two dimensions, right? In this case the two dimensions are reduced to the nanometer range and one dimension is having the size more than 100 nanometer. It remains large. Say for example nanowire, it has its one dimension more than the 100 nanometer, right? Nanorods, nanowires, nanotubes and the carbon nanofire would also come in one-dimensional nanoparticles. Then two-dimensional. In this case, the one dimension is confined. One dimension is restricted. It is in between the or in a, it is in less than the 100 nanometers and two dimensions remain large. So in this case the electrons are allowed to move along this two directions. Examples: graphene, nanolayers, nanosheet, nanowells, nanofilm and the nano coatings. Three-dimensional nanomaterial. In this there is no confinement in a nano range. Means here the movement of electron is allowed in all the three dimensions x, y, z. Here electron can move in all the three dimensions wherein the thickness of that material is more than 100 nanometers. Actually this would not going to come in a nanometer. or the nanoparticle, actually it is a combination of agglomeration of either the one-dimensional particle or a two-dimensional particle or a three-dimensional particle. That's why we can say it is a bulk nanomaterial or a nano powder. So these are the certain example, like these are the pictures of a fullerene, zero dimensional or a quantum dot we can say. Then the one dimensional carbon nanotubes, two dimensional graphene, and the third dimensional is a graphite. So thank you very much.